Hi, welcome to this video that is an introduction to the concept of volume. Before I talk about volume in particular, I want to first just review two types of measurements that I'm sure you're familiar with. When you measure something with a ruler or a tape measure, that's called length. It's measurement in just one direction, one dimension as we say. And you can see the usual units that we use, including also things like inches and centimeters as well. Then we talk about something called area, and area is different from length in that there are two dimensions or two directions that we take measurements of, and we're really saying how many of the little individual squares would be needed to tile the whole surface. Now notice I've written the dimensions as 7 rows and then 12 different columns. So if I wanted to know how many little squares are covering that blue rectangle, I would say there's 7 rows, each having 12 boxes, so that's 7 sets of 12, which is also 84. 84 what, you ask? Well, 84 square units. If these had been square inches, I would write IN and then put a little elevated 2. But in this case, because no specific units were given, I just say square units. Again, I'm emphasizing the part that says I'm putting little squares to tile the whole surface. Now we move on to volume, which is different from length and area. See, length has just one dimension, one measurement. Area has two different measurements. And it's like seeing how many squares it takes to tile a flat surface. But volume requires 3 measurements. So volume is a measure of the capacity of a three-dimensional object. In other words, how much air or water or sand could this container hold? Another way to put it is, how much space does an object occupy? Unlike area, which tells us how many 1 by 1 unit squares are needed to tile a flat surface, volume tells us how many 1 by 1 by 1 cubes there are in the object. You can see some of the common units that are used for volume. The object shown to the right is your basic shoebox standing on end, more formally called a right rectangular prism. It's considered a prism because the top and bottom faces are congruent to one another. It's called a right prism because the vertical sides, all 4 of them, here are the 2 that you can see, all make right angles with the top and the bottom. Finally, it's called a right rectangular prism because the congruent top and bottom faces are in the shape of a rectangle. To find the volume of a right prism, we find the area of the base and we multiply it by the height. Since the base is a rectangle, I need to go get my formula for the area of a rectangle, and I'm using length times width. And then my height I'm going to let be represented by h. So to find the area of my rectangle, it's going to be 4 times 3, and then times the height, which is 5. 4 times 3 is 12, times 5 is 60. And the units for my answer would be in cubic centimeters. A cubic centimeter is one of those little boxes which is 1 centimeter by 1 centimeter by 1 centimeter in size. So there are 60 of those cubic centimeters. If I had chosen to write cubic centimeters with a symbol instead, it's written this way right here. But even if I write it this way, it's still read cubic centimeters. Notice in our formula, the area of the base computes how many of those little cubes fit on just one layer of the figure. And then multiplying it by the height tells me how many layers there are. So the reason it ends up being 12 times 5 is because each layer has 12 little cubes, and then there's 5 of those layers, so it ends up being 12 times 5. Here are the first two of three problems that I've provided for you to try. The top one is a right isosceles triangular prism. The isosceles triangular prism has an isosceles triangle for the top and bottom. The next one is the right hexagonal prism, which means that the top face and the bottom are both regular hexagons. Regular, if you remember right, means all sides equal. And I've marked out a couple of necessary measurements that you'd need to calculate it. I recommend that you pause the video here and try these two problems first, remembering that you calculate the volume of any prism by taking the area of the base and multiplying it by the height. The third and final problem for you to try is this cylinder, which is another name for a right circular prism, and I've given you over here the dimensions that you'd need in order to calculate this. And remember, again, it's just a prism, so we calculate the volume in the same manner. Please pause the video once again and finish this final third problem, and then bring the work from all three problems to class next time. I hope that this video has been helpful.